Now, I notice that these two denominators aren't the same, so I can't add them directly. I'm not counting the same thing, and that's what the issue is. So the first thing I need to do is to find the LCD. So I'm going to look at dem 1, and dem 1 is 2x squared, which is 2 times x, and dem 2 is just x. And you can't do anything with that. So what's the LCD? LCD, dump 1 in. So 2x squared is there. I need 1x, and I've got 2. I've got more than enough. So the LCD in this case is going to be 2x squared. So that means I need to take 7 over x squared, 2x squared, and I need to turn it into a denominator of 2x squared. And what do you notice? It already is, right? So the most I could do is multiply by 1 over 1. So he's okay just the way he is. Then I need to take 4 over x, and I need to turn 4 over x into a denominator of 2x squared. Well, in order to do that, I need a2, which it doesn't have, and I need a second x. But what I do to the denominator, I must do to the numerator of the fraction. So this becomes 8x over 2x squared. So now we've got a problem like we were working yesterday. I'm now counting the same pieces. I have 7 circles plus 8x circles. How many circles do I have? Well, over 2x squared, I have 7 plus 8x. And because this is a grouping, I can't reduce anything down unless it factors, and it doesn't. So this is prime. So that says, that's all she wrote. That's your answer. Now, dem 1 is x plus 7, and dem 2 is x minus 2. Remember, these are really groupings, so they come as a clump. They come as a complete entity in of itself. So that's going to say LCD is x plus 7 times x minus 2. Now I'm going to take the two fractions, and the first fraction is x minus 2 over x plus 7. I need to turn it into, it has to have a denominator of x plus 7 times x minus 2. Now to do that, it already has an x plus 7. Remember, these are, because of additions and subtractions, a grouping. X plus 7, x minus 2 already has an x plus 7. It needs an x minus 2. Now I'm going to leave this as it is. And you're going to say, why? Because I'm going to have to multiply it out. And I'm going to have to use FOIL to do so. And if I wanted to, I could. This would be what? X squared minus 4x plus 4. So that's the first fraction. The second one is x plus 7 over x minus 2. And again, I need to turn it into x plus 7, x minus 2. This is an x minus 2. What it needs is an x plus 7. So that's my denominator. My numerator then becomes x squared plus 14x plus 49. Now those are the two fractions I'm going to add. The thing I have to remember most, by the way, is that since this is the addition right here, this added to this, the second one and the first one too, they both have sets of parentheses around that grouping, but especially around the second one. Now it's not going to matter because of this plus sign. So we're going to take the two equivalent fractions. So x minus 2x plus 7 turned into x squared minus 4x plus 4 over, and I'm just going to say LCD because I don't want to write it all. This one turned into x squared plus 14x plus 49. Now I'm counting the same thing so that over the LCD I'm going to take, and remember this guy's got a set of parentheses. With that plus sign there, it's not going to matter. If that were minus, it would. It would be x squared plus 4x plus 4 plus x squared plus 14x plus 49.
Shouldn't that be a minus 4x?
That should be a minus 4x. So plus x squared is a 2x squared. Minus 4x plus 14x. And plus 4 plus 49 is plus 53, and I say whoopee. And why would I say whoopee? 53's prime. Only way I could write 53 is 53 and 1. The denominator, or LCD, is x plus 7, x minus 2. The only way that I could reduce this down is if 7 was a factor of 53 or 2 was a factor of 53. That I could write that as x plus or minus 7, or x plus 7 times something in the numerator. But 53 is 53 and 1. So that's all she wrote. So it is definitely a yippee.